Still waiting.
Hold on. We get the last link so that we can have you coded properly. Hope your members are Greek, science, and animal.
They are aware of the meeting.
Yeah.
We are here, ma. We are here, ma.
So I'm about.
Okay, good.
We are here, ma.
Yes, I'm taking in.
We are around, ma.
Because once we
We
start,
are around, though.
we will not be admitting people in via the live stream.
We are already in. We are already in, ma.
We are here.
Right. Okay, so I'm admitting in the last person.
Okay, so I'm admitting in the last person.
Because once we start,
not
admitting people
in.
Can you see my screen? I'm admitting it. The last person. Okay,
So I'm admitting
Mr. Tunde, you can now start. Unmute and start. Please, no mic should be on.
All right, can you hear me, ma? To mute the thing.
Yeah, move yourself, sir. Start.
Okay, good afternoon, honorable teachers of District 6. We are here as a group from agriculture, science, and animal science teachers to present the topic on the possibility of farming in space, taking Mars as a case study. Now, space, a lot of research has gone into space exploration, space satellite sensoring and data collection for analysis on Earth in order to, better the lot of livelihood on Earth. But the latest research in agriculture is yet to be perfected and it is still ongoing. That is why we need to let you know, bring you to speed to what is happening on the research concerning agricultural innovations in planet Mars. The planet Mars is the next planet after the Earth. It is not yet habitable, yes, but as the part of this slogan, there should be a limitation as to science. So science has made its own effort in ensuring that there is livelihood, the possibility of livelihood on Mars. And the first thing to do is to plant crops or plants that will be what you call in biology, biology and agri, they are very interrelated. Plant is the first colonizer, the first producer. And if you are going to expect life, other organisms to come into a particular colony, you need plants. It is plants that will invite other organisms to come in. And planting of crops that can survive in the very harsh weather condition is very, very important. So that's the essence of looking at the possibility of our topic, looking at the possibility of, farming in space, taking Mars as a case study. Now, let's go to the introduction proper. Let's go to the objective, learning objective. It is expected at the end of this presentation that our students should understand the basis of space farming. Why space farming? Why do we not have to go up the way to the space to farm? They should be able to understand that at the end of the presentation. Then, to achieve this, what are the specialized tools? What are those specialized tools that we need to, use to achieve this seemingly impossibility that we want to make it possible? We need those tools, specialized tools that are not just simple tools we are talking about. We need technology, use of the application of technology, we can go to define and goes on in this course of this presentation. Now, the third objective we are looking about is, have to recognize the importance of sustainable food in space. How can it be sustained? So that this aspiration of Elon Musk, rather, that man that is aspiring for people to go to Mars to live. You cannot go to a place to live if you don't have food to eat. So we need to think about how can we sustain food production in Mars. If we say is food enough in the Earth, yes, it's not still very sustainable on the Earth. But what about those scientists, space scientists, astronauts that are going to be exploring for us? They will want to stay there for long. Can you understand? They want to stay there for long, and staying there for long, they need food. Like those astronauts that just had that they got stranded in the space. They need to be feeding on something. So those are the three objectives we are looking at when it comes to this presentation. So let me just for now define space farming. From that word space and farming, what is space? Space is an unoccupied place where active living organism is absent. When I say active living organism, which means there are some particular organisms that can still survive that extreme condition. How are they doing it? We need to research, need to be done on that. You know, when that presenter was presenting for us, I think it's one of the biology and science. I remember it's biology and science. He was talking about extremophiles. One particular organism that can survive such hard weather conditions. Our students will be told as time goes on to research on that. So extremophiles can survive. If extremophiles can survive, what are those parameters? What are those things that make them to survive? Research needs to go into that as well. So that is space. So what is farming? Farming to us is the deliberate act of planting crops and rearing of animals. Crops first, plants first, is very, very important. Crops need to grow for animals on the crops. So that way we are talking about crops for now. Crops is fundamental, is the foundation of every colonist, because photosynthesis, they trap energy from the sun and then transform it through energy transformation to other organisms. Now, if that is space and farming, so what is that space farming? Space farming, I define it as, a deliberate act of planting crops in space using the application of science and technology. We cannot do without that. Application of science and technology. The knowledge of science that we have known from this earth, and the technology-wise, through gadgets. I'm talking about robotics now, robotics engineering. Robotics engineering, where, okay, we can move on to slide 2. Sorry, we can move on to slide 2 now. Let's get to slide 2. Thank you so much for that, for sharing it. Now, slide 2 is talking about, if you look at the heading of slide 2, it's talking about images of hydroponic gardens. Now, when we get to that place, that Mars we're talking about, what are those things we are going to use? What is that science that I'm just talking about that I'm going to use? I'm talking about hydroponic gardens. What is hydroponic? That word hydro means water, and phonic means plant. So plants that can survive in water. There are plants that can survive, that are surviving in water even on this earth. Those are bryophytes. Those are teaches biology. Unfortunately, although I'm a Greek and I've been deployed to teach biology for some time now, I'm still in biology. I teach Greek in JS classes. Now in senior classes, I'm co-op to teach biology. So I'm privileged to know bryophytes, those plants that can survive in water. I think, is it bryophytes? Maybe I'm mistaken. There are some plants that survive only on water. I mean, those seaweeds, that are, that float on water, water hyacinth, they float on water, they have their roots embedded inside water. How do they survive without soil? So that is the science I'm talking about, that we're going to export to the mass. Then the technology aspect of it, we are going to construct, there'll be a construction of greenhouses. You know what is greenhouses? Those inflatable greenhouses. The houses, the inside the house where the plants are going to be kept for their growth. Now, inside these greenhouses, there must be a controlled environment, as if the plants are naturally in their natural habitat. The mass is so cold, just like in maths. If you look at the maths presentation, the maths, they let us know that the temperature of the mass is extremely cold, and there's no plant or human being that can actually survive in that cold weather. So they need a house where the inside of the house can be controlled. That is where we talk about technology. There will be an air conditioning or ambient, that will serve an ambient temperature, controlling the internal environment where the plants are hereby planted. Now, the plants, according to the slide we are on now, you will see that there are some tables that are set where the plants are growing. Underneath the table is water, and not just water. There are inorganic fertilizer growing that are being mixed with that water at a particular concentration. Depending on the growth, as time goes on, the plants will require more of the nutrients. So the concentration of the water will have to be changing as the plant increases in sizes. So who will be there to increase this concentration? That is where robotic engineering comes in, the aspect of technology. Robots can do that for us, and that is where we need those scientists, those engineers, that we have to design robots that will control the ambient temperature of the plant, and also help us to be increasing the concentration of these soluble in the soluble nutrient, that is the inorganic one, the fertilizer that has been mixed for the plant growth. From the picture, you can see that there are mostly vegetables. Tomato can be grown. What other one do you think can go? That thing can go. Tomato can be grown. Pumpkins, all those living vegetables can be grown. As time goes on, as this research goes on, probably 3 crops will be encouraged. It is for now limited to all these fruity, leafy vegetables and fruit vegetables like tomatoes, okra. That one can grow because their roots can survive in that water. Even on heads, there has been research where underground, under this zero ground, tall buildings, you have zero ground where it's always dark. I've seen a research whereby a tomato are grown in a very dark place. What they do is that they just light up the place and regulate. They just regulate the hours of light in which the tomato will be. That is the daylight, and then off it for darkness. Photosynthesis takes place between the day and night. If you are biology person, photosynthesis takes place between day and night. Hydrolysis of water takes place between the day, and then the actual formation of starch takes place during the night. The catalysis of water and the rest. So carbon dioxide and water will now react during the night. But the water has to be splitted to hydrogen, to ions. And that was we call it photolysis. That's the science that I'm talking about has to put that we're putting in it. So let's move on to, before we move on to slide 3, you can see some of the gadgets that are used. There are pipelines. Those pipes are embedded in the
We can't hear Mr. Tunde. I guess the network has struck. Is there any other person from Agric Science that can continue? Anyone? Any representative for agricultural science who can continue from where Mr. Tunde stopped?
Hello, ma. Hello?
I can hear you now.
We can hear you now. We can hear you now. Yes, we can hear you.
I was just going on. I didn't know it was off. Am I on now?
Yes.
Okay.
You are.
Yes, you are on now because we are hearing you.
So I will continue right now so I don't know where you got me off. Where was I, so that I just retract my
You were saying something
back to that.
about all these pipes.
Okay, I was talking about the pipe that inside the pipe there are water. It supplies water to the plants, and inside the water we have, so it's a solution of inorganic fertilizers that supply nutrients to this farm in the greenhouses. So that's one of the those are one of the equipments that are used in that inflated greenhouse, which can be sited or constructed in the mass to control the internal environment of the plant for normal plant growth, as if just to make the plant feel at home, as if they're on planet Earth, where the atmosphere is somewhat friendly to them. So that was what I was trying to say. I think I'm now in slide 3. You can move it to slide 3.
Yes, sir. Is this like?
Yeah, this is slide 3.
Okay.
Yes, it's slide 3.
Okay.
And we have space-friendly farm tools. When I say space-friendly farm tools, we cannot use simple farm tools right there to carry out these operations. It needs sophisticated equipment, and we are looking at robotics carrying out this farming operation for us. Human being cannot be there because of the weather condition. So we need robotics that will be programmed to water to change these concentration and to tend the plant. You know, as the plant grows on, like I said earlier, they will require more nutrients. So the concentration of the water solution will have to be changing as the plant is going. All these data analysis have to be taken from remotely controlled robots. So that is where I was saying that technology, you know, when I define space farming, it involves both science, the knowledge, the application of science and technology. We need robotics. So that's where we are going to. That's what I'm talking about. So in this slides, you see robots doing the work of men inside that place. So robots can farm for us, and then they can't do it on their own without being programmed to do exactly what they need to do for us. They will put water concentrated. They will have they carry out similar farming operations that will help the crop to grow. So let's move on to slide 4. So still saying, this one is telling us images of plants growing in space. All right, these are images of plants to show that in space, research is going on to improve the livelihood on space, because this is going to be very crucial for human existence in space. If they go there and there's no food, sustainable food there for them to eat, to carry out the space exploration, they will not be able to extend their stay. And the research will not be easily concluded on time. So food, sustainability of food is very crucial. That is why I'm still showing these images to show that research is going on. You can see some other rollers going within farms, those green farms. These ones are pictures taken from space, International Space Stations. So they are there to, better the life of space explorers. As time goes on, they are talking about space tourists. Tourists can even go there, view all this for their own pleasure. I think you can get there as soon as possible. Thank you. So let's go on. Let's move on to slide 4 rather. The next slide, ma. Hello, ma. Are we with me? Okay, thank you very much. We are now in the. All right, we are now in the second to the last slide, and this one is talking about future mass colonization. I've been talking about it ever since. We need to colonize the mass for tourists, for scientific exploration, for studies to better the lot, to be integrated into our curriculum. You can see that the soil, which I forgot to talk about, that the soil on Mars cannot be grown. Research has gone there that this soil is somehow very silty as a result of volcanic eruption. The soil evolved from volcanic eruption. So this soil contains minerals like iron. That is to say that there is possibility of exploring iron on Mars, which can also be an advantage to planet Earth. You can see, if you scroll back to the first side, you see that the Mars is somehow red, showing a significant existence or mining of iron, which is possible there. So I'm just saying that for scientific research purpose, which other science can also take note. But in agric, the best way for now is to construct greenhouses. Greenhouses, I mean inflatable greenhouses that are light-led, that are technological driven, the use of robotics. So that is what I'm trying to say. If you look at the slide, you see the round greenhouse and the pipe going out from there, and the sand, the soil around it cannot be used for agri. But water, which is hydroponic farming that I've said earlier, can be practiced on Mars. So that illustrates the means of colonizing. The light is off. I hope you can see me. Hello, ma. Hello.
Should I go to the next slide?
Yes, I can go to the next slide, but the light is off. Can you see me? Because it's somewhat dark. The light is off.
Yeah, don't worry.
We are not seeing you.
Eh?
We are not seeing you. We are not seeing your picture.
And because the light has not been taken off, it's just the light has been taken off. Hello, the light has been taken off. It's dark here. It's dark in where I am now.
Just
It's
continue.
your voice we
You have
need
the
now.
screen.
Continue.
All right. So the next slide.
Continue discussing.
Okay, the next slide is talking about features of innovative inflatable greenhouses. To carry out these farm operations, we have gadgets that can be used that I've been talking about ever since. Is inflatable greenhouses that are lit with LED lights. These LED lights can also supply photostatic energy for the plant to, manufacture their food through photosynthesis, considering the atmospheric temperature in there. So that is what I'm talking about on the slide. There are pictures of those inflatable greenhouses. You can see it there. It's possible for us to. It has been practiced on Earth, and it can only be done on space with more science and technology-driven purpose in there. So that is what I'm talking about. So let's move on to the next slide, ma. Are you with me, ma?
Yes.
All right, let's move on to this. I think we're on the last slide. We should be on the last slide now.
Yeah, we are on. Okay, you can hear me. We are talking about of innovative materials like.
I've talked about that one. Inflatable materials, inflatable greenhouses that can be used to enhance the growing of crops, most especially fruity vegetables like tomato, okra, and leafy vegetables like pumpkins and other ones that can be, for now, practiced on Mars. So we can move on to the last something. Can move on to the last slide. Okay, the last slide is just telling us how we have simplified the process of presenting this presentation. So it's just that. And then we can now integrate it into our students. All this we are talking about is to let them draw or design a greenhouse that can, replicate these inflatable greenhouses, at least to let them feel that these greenhouses can also be taken to the space for space exploration in farming. So I'll be ending the presentation from there. Thank you.
Thank you.
Thank you so much.
Well done. Fantastic presentation from the agricultural science and animal husbandry should actually for themselves alone. So we will get more teachers involved because animal husbandry should be something about animals and all. Yeah.
Animal husbandry is not done by the science students. It's done by the arts students. They split it from agri. So it's a trade subject.
And that's not a problem. We are talking about STEAM.
Scheme, okay.
Science, technology, engineering,
okay.
Art.
Understand.
Art. Mathematics.
All right.
Okay. So it's that part, that time.
It's inclusive.
Yeah,
it's inclusive.
Yeah, everybody come on. Okay. And let's get prepared. We are streaming live. On so please ensure you are gorgeous. Thank you. You understand what? Yeah. Are we ready?
We are ready.
Oh, yeah, go from that place. Wait.
I want to say more.
Wọ́n ṣe máa ń ṣe nìyẹn. I have to run away from home, otherwise. You have 20 teachers. Okay, right. So let's go. On my count. Three, two, one. There we go. Let's take one more.
Right now.
Don't cry.
Baby. Baby agriculture.
All right.
Go to
Three.
teacher agriculture. No.
Baby agriculture.
3, 2, 1. Got y'all. I got y'all.